technology.
Yeah, so thank you for that. First of all, I love being associated with Iron Man. I wish I would look like Iron Man. Sadly, that's not the case. But what I really, really enjoy doing is just playing with science and playing with different things that happen to be in my backyard. And this is pretty much what I do at the moment, just that I don't own a backyard. I own a balcony and a smaller apartment because I'm a student. But I still really enjoy inventing and playing with science. And that's something I think you all need to do when you get home. So if you still have that box of Legos from your childhood in your attic somewhere, please, as a promise to me, take that out and start playing with it this evening. Promise? Okay, good. So now I can begin. So I grew up in West Cork in Ireland. So essentially in the middle of nowhere. Like my house was the third last house on the electricity line before you fall off a cliff and get into the ocean. And really to get to a city was like really, really, really far away. But I did realize something that I loved, and that was being outside in nature and being outside and being able to connect with the environment and experience it. I did a lot of sailing, a lot of kayaking, a lot of walking on the coast. And these are sunny days in Ireland. I don't know if any of you have been to Ireland, but sunny days are actually not that common there. We also have rainy days, and on those rainy days, I was playing with my Legos and Arduinos and trying to build different devices to do whatever I wanted them to do. And ultimately, that taught me two things. One is that I like environment, and two, I like inventing things and playing with things. But while out in the environment, while sailing and while kayaking, I saw a lot of plastic on our shores. And at first, it was just something that annoyed me because I felt like it looked kind of strange and out of place and colorful, but I didn't really know the problems associated with it. And I thought, well, these big bits of plastic, well, what animal would want to eat this? How would this get into an animal? How would this harm an animal? And that was something that at first I didn't really worry about, but more I just thought was something that was annoying. But I decided to look more into it, and that's when I started coding and playing with a couple of little robots and things to just casually go along the coast and identify plastics and be able to count them from an image. I actually coded a macro for Adobe Photoshop that if you took a picture of a coast, it would try and identify plastic. And like that, you could actually quantify maybe the plastic on the shoreline. So as a result, I realized there was actually quite a bit of this stuff there. And it wasn't the same plastic, which I initially thought, but new plastic being washed up and being washed away with the tides on the Atlantic. And then I did some more research into what was happening to this. And that's when I realized that there's, the small microplastics, which we've been talking about for the last half hour or so. And these small microplastics were something that I got quite scared about because I just saw that, they're really, really small, but also they're really difficult to test for. A lot of people are talking about how, there's X amount of microplastics in this product or there's X amount going into the sea every day. I think that's a really unrealistic estimation. I think there's probably a lot more microplastics going into the sea every day because it's basically impossible to test for these microplastics. And that's actually the first thing I hope you take home from my talk, is that microplastic testing is still such a big complication and such a big requirement for us. We really, really need to develop new technologies to test for plastic. But I thought, well, I'm in the middle of nowhere in Ireland. I'm quite far from the nearest lab, like 4 hours drive or so. I couldn't drive, so that already solved that problem. But I thought, what if I use my Legos to build a device to test for plastics? And that's essentially what I started off with. Out of my Legos and out of a camera, I built a visible light spectrometer. So the theory behind that is that if we shine light at a sample containing plastic, the molecules inside the plastic start getting excited, just like me when I came onto stage with the music. And that changes the light that goes through. And then what we get back is something missing a couple of parts of light. And those little bits of light that are missing, that is what's telling us that there's plastic there. So I built one of these. This was not easy. I had to take apart our fridge and a couple of other things to get components and then try and put them back together before my parents found out. It also caused a couple of power cuts in the district, but nothing that couldn't be handled. But I realized that actually I could create a pretty interesting piece of kit to test for plastics relatively simply. And that's what I did. So I started testing for plastics, and I realized that plastics were literally everywhere. So much so that the water that was coming out of my tap from a 200-meter well beside my house contained plastic. And when I washed my equipment with it, I was actually leaving behind plastic. I don't know if, yeah, Imogen, you have this issue as well, that when you're actually working in a lab, it's so difficult to not contaminate your samples. So when I was working in a lab, I wore an orange lab coat so that then I would see orange pieces of plastic if there was plastic coming from the coat. But with that, I realized that there was plastic, and this was very small plastic. So small that a filtration technology, a filter where we can put water through, just wouldn't work. Because some of these plastics are so tiny that they can be smaller than red blood cells in terms of just a couple of monomers. And then we're getting into a molecular scheme. That's why I thought, well, what if I think back to high school science class, right? And think back to ways that we can separate very different nature molecules from a bulk solution or bulk suspension of other molecules. And I thought of something that probably most of you did in high school chemistry class, and that was a liquid-liquid extraction. So you put one layer of something of one polarity on top of another, and you can actually perform an extraction, right? So nonpolar things will tend to be solvated better in a nonpolar solution. Sorry, guys, I'm going to try and limit the chemistry as much as possible. But ultimately, I was able to use an oil mixture to extract plastics out of a bulk suspension of water. This worked reasonably well. I tested it with my makeshift little machine that caused the trip switch to trip every 20 minutes. And I saw that this method worked relatively well in the removal of microplastics from water, so approximately 80%. But what do I do with oil? I've got oil sitting on top. We don't want to build oil spills, right? So that's what I thought, well, what if I turn to my physics class? I was 16. And what if I use a magnetic suspension? So I add some little magnetic particles into the oil, ideally magnetic particles that are safe for the environment. And then those magnetic particles, I can basically turn the oil into something called a ferrofluid, or magnetic liquid. So I start playing with this first, just playing with ferrofluid, because they're pretty cool. They make like nice star-shaped structures when you put them in a magnetic field. But then later, I discovered that these could be used to attract microplastics from water using magnets. And actually, I then did a very, very small experiment. I still have the original video, which I gave to the technical department. So if they could put it on at some point, that would be good. Like I have, oh, here we go. And I basically started by adding microplastics to water just to see. And then I added some just plant oil, cooking oil, and then a little bit of magnetite powder. So this black stuff, this is like rust powder. And then I mixed it up, and it looked pretty manky, or dirty. In Ireland, we say manky. And then I brought in just a test tube filled with magnets. And I wanted to see if I could attract the mixture of both the plastics, the oil, and the magnetite together. And would this be a reasonable or viable method? And it looked like it worked pretty well. So that's what really started me on this journey. I don't have quite enough time to, I guess, explain everything that I've been doing since. But for me, this looked like it worked relatively well. So that's why I thought, well, what if I build a better version of my visible light spectrometer and build a backup device, as one does, to test this in 2 ways. I think 2 is better than 1. So I built this visible light spectrometer and a microscope, and then paired those 2 technologies to try and look at microplastics. And I saw that my method, at least on a scale like this, in a little test tube, was effective to approximately 87%. But I wanted to see how we could apply this into the real world. And that's what I'm currently doing and still doing. So I tried, and with the funding of Robert Downey Jr.'s Footprint Coalition, I've actually been able to create this into a continuous flow device. So a device where water flows in, and it goes through a layer of this magnetic suspension, and then the plastics hopefully stay in that suspension, and then it flows out through a series of traps. I can't show you a picture because this is still something in development. But when it's out, yeah, if you follow me, or if you reach out to me and want a picture, yeah, sure, I'll send you one. But this device is showing really, really nice results and really exciting results. And for me, it's not just about creating a technology that we can clean up plastics with, but more about the journey of seeing one of my little things that started as a couple of blocks of Lego and a little bit of kayaking on the coast in Ireland turn into something that perhaps is something viable and useful and something that we can use to actually change the way that we live. Microplastics have been seen to cross the blood-brain barrier, and they've also been seen to be absorbed relatively easily. However, this is all very continuing and ongoing research. But what I believe is that we all need to engage a little more and play a little bit more with our science. I think we shouldn't be afraid to just leave the innovation and the idea generation to scientists, to people in labs, because often they are in that lab and they perhaps have not got the exposure that you have to the world. Everyone has a unique place in the world, and I think that through perhaps exposing yourself to multiple things and letting any one of your ideas count, I think you can truly make a difference. But something I would also like to highlight is that what I've created here, I do not think is the solution, right? Because I'm just cleaning up plastic. But the ultimate solution is that all of you guys stop creating plastic and microplastic waste and perhaps try and redesign the whole ecosystem of plastic. And I think that's not just you, but also bigger companies. So that's why I'm actually currently working on trying to get more companies involved. I'm actually launching an NFT-style project where I think we can use blockchain technologies to reward companies for their goodness in terms of not producing plastic pollution or microplastic pollution. And through this, we can perhaps reward companies with an NFT, which they can then use on branding of their products. So this is just a very grassroots idea which I have, which I'm actually pretty much launching and bringing to the public here for the first time. But it's another result of me kayaking on the shore. So ultimately, I've achieved just a couple of small things, some of which I think could make a difference in the world, some of which I think could perhaps change the way we interact with plastic and work with plastic. But ultimately, this has been a result of me playing with science, and I urge you to all take out that box of Lego and play with science this evening and hopefully into the future. Thank you.
So Fionn, thank you, but I'm a bit disappointed because you said that was not the solution. But so where can you apply this solution?
Well, I think it perhaps could be one of the many solutions that we could apply for cleaning up plastic, right? Plastic, even if we stop producing microplastic pollution today, will still be in the environment for many years. And it's something where I think lots of cleanup technologies like my own and the ones that are going to speak right after me could help. Right? Because we still need to try and make water and different things we're going to consume safe for us to consume. I don't want to be consuming those 5 grams of plastic that I currently am through my water and through my food. And that's why I feel like technology like mine and other cleanup technologies are important. But they're not just important for that, but also in the importance of raising awareness, like what we're doing here today in this amazing event. We're reaching out to more people who hopefully learn about the microplastic issue through technologies like these, but also we're hopefully sparking some ideas in people like this amazing audience to change things as well.
Okay, great. And would there be some specific cases of applications, such as, I don't know, industrial waters that are polluted with microplastics, or what kind of applications do you foresee?
Sure. So I really think that this is not a technology that we should just apply in the ocean, like dumping in lots of magnetic liquid and then, holding a magnet at the beach. I don't think that's going to work. Sorry, guys. But I think a place where we could apply this is perhaps in places where polluted water is coming into the waters of the world, or where we're taking water out. So perhaps in wastewater treatment centers or effluent treatment centers, where we've got a lot of plastics in a very, I guess, well-defined scheme of water. That's at least where my research is currently going. But also in places where people are drinking water. Perhaps one of the best technologies for cleaning water in terms of having clean water is reverse osmosis, which would probably take out many plastic particles. However, reverse osmosis is not something that is very energy viable, but also is really, really slow and not efficient to, let's say, use on a whole water supply for a city. So that's a place where I envisage my technology perhaps working as well.
Okay. And if some people want to know more about your work and want to engage and support you, how can they do this?
Well, I really think that it's important that we foster, interesting conversations and hopefully talk about our other creative solutions. Like, I'm totally down to brainstorming with all of you. Maybe like not all at once, but at some point. So I really use Instagram a lot because I feel like that's a place where we can connect and brainstorm about ideas, and I can also learn more. So just with my name, I think you'll find me. I also have a platform which is very much in the early stages, where we're looking at just creating a small community of focused scientists who are sharing tools and methods to be able to do science or to work on their own creative ideas. So that's called Glick. You can find it at theglick.com.
Great. So thank you very much, Fionn.
And thank you for having me.
So this gave us a view of one promising solution to treat at least one part of microplastics. But as the microplastic issue is huge, we cannot rely just on one technology. So we need a lot of entrepreneurs that will be looking for solutions for different types of solutions, different types of applications to get rid of this problem. And also, as Amy and Imogen said, also be very careful ourselves to change our habits to always create as little microplastic as possible. But for the next part of this session, let me introduce to two young entrepreneurs that also created some startups to fight against microplastic. So we have Jamie Walters, that co-founded Galixia, and Adam Roots, founder of Matter. Please come on the stage.